greater than negative 2 mean? We fully understand what does x greater than 4 mean. Can you give me examples of numbers that satisfies this? Satisfy the inequality on the left. For example, x could be negative 1. What else? 0, 1, 2, 3, so on and so forth. Okay, all sorts of numbers, right? Can you give me examples of numbers over here that satisfies the inequality on the right? Okay, x equals to 5, 6, blah, 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 right? What about now? Give me a value of x that satisfies both of them at the same time. Huh? What shall we start with? 5? Why not negative 1? Because it needs to be bigger than 4 also, simultaneously. It needs to satisfy both at the same time. Okay, so we naturally we will say 5, 6, 7, blah, 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 right? Can it be 4.1? Yes, as long as it is greater than 4. Is it difficult? No, simultaneous equation, simultaneous linear inequalities. This is the most basic question that we can have. Things can get a bit more complicated. So that is why, instead of just looking at these two linear inequalities and deciding that, hey, actually, everything that is inside here is going to satisfy this, just by thinking of it this way, may not be enough when we come to more complex questions. So we need to have an approach that is going to help us find the solutions for simultaneous linear inequalities. Okay, so let me draw number line. We see how it's going to be useful. So this is my number line for x. What do you think are my values on my number line that I am interested in? Negative 2, yes, of course I'm interested in negative 2. Any more numbers that I'm interested in? 4. Okay, now what is the first inequality that I have? X greater than negative 2. Should I draw a hollow circle or a solid circle? That means I color it hollow. Then I draw an arrow to the left or to the right? Right. So this arrow over here tells me that as long as I have a number greater than negative 2, this green color area, I will satisfy this. Agree with me? Anywhere along this x-axis, as long as it is greater than negative 2. Let's find out. What about for the other inequality? Let's use blue this time. Okay, this linear inequality, it is greater than 4. So hollow circle, right? Over at 4. Arrow to the left or to the right? The right. Okay, so we all know that all these arrows, arrowhead means that it extends all the way to the right. Just keeps going on and on. Okay. For the blue color region, we are talking about this part, right? Agree? Now, this is what we need to draw for simultaneous linear inequalities. We are going to find the area, the region, where there is an intersection. How many regions do you see over here in my number line? In my diagram over here, how many regions do you see? 2? Okay, can you describe the first region? The red one, from where to where? First region, from where to where? You mean this region? Okay, this is the first region that she identified. What about another region? 4 to this part. You all agree? Can we divide this into separate regions? Okay, what are some separate regions that you can find? Do you agree with me that this is one region? Do you agree that this is one more region and this is one more region? Okay, we've got nothing smaller than negative 2. Between negative 2 to 4, yeah, it only satisfies one linear inequality. But greater than 4, it satisfies both linear inequalities. Do you agree? And that is my answer. We look for the region where it is shaded 2 times. Or we call it the point of intersection, the area of intersection. So this part we didn't color at all. This part we only colored once, green color. This part we colored it twice, green plus blue, and that is the region I want. Therefore, my answer will be x is greater than 4. Should I have, okay, let me give you a question. X greater than 4 or x greater than or equal to 4. Which one is it gonna be? Number 1 or number 2? Which is the answer? 1 or 2? 1. Can I include the value 4? Cannot, because once it is 4, then it doesn't satisfy this anymore. It must be greater than 4. Okay? So from the graph, you must be able to describe regions. Okay, so let me demonstrate describing the regions to you. This region, the first one over here, what shall we describe it as? X is less than negative 2. Is it less than or equal to? Less than or equal to, okay? Because this portion over here, we're going to call it X. How do you describe this region? X is greater than negative 2, but it is smaller than 4. Okay, let's call it smaller than or equal to 4. How about this part? X is greater than 4. Get it? So you are supposed to be able to identify which one you are going to use. Arif, can you move the bottle away? I can't see your eyes. Okay, now part B. Part B, X is less than or equal to 1 and X is less than or equal. And X is less than or equal to 7. Okay, shall we draw the number line? Okay, easy. This is my X, this is my 1, this is 7. Okay, first in linear inequality, what does the number line look like? Solid or hollow? Solid or hollow? You must be very certain, no? Huh? The first one. Hollow, Arrow to the left or to the right? Left or right? Left or right? Left. Okay. What about the other one? Solid? Okay. To the left or to the right? Left. Where is the area of intersection? I think you can all tell it's this part, right? But how do we describe this? X is less than 1. Okay, now I give you another question. Is it or X is less than or equal to 1? Decide. Is it less than 1 or less than or equal to 1? This portion over here that I'm shading. It must be less than 1, huh? Why? Because sorry. Yeah. My mistake. It says X less than or equal to 1. Okay, so in this case there is nothing to decide. It's obviously going to be X is less than or equal to 1. I copied the question wrongly.
But if it's like 1 is less than the other.
Okay. So let's say I have a question that looks like this. If I have a question that looks like this, can you tell me whether the value 1, is it included or not? Look at the arrows above it. Do I include the value 1? No, I don't. This one, do I include? I include over here, right? Then I have a include and don't include. So what should I do? Include or don't include? It must both be satisfied at the same time. Yeah, that's why the only logical answer is that we don't include. Okay? But in your textbook, the question is less than or equal to 1, so we include it. Okay? Therefore, X is less than or equal to 1. Okay, let's do part C. X less than 5 and X greater than or equal to negative 1. Similarly, number line, we've got a negative 1 on the left, smaller number on the left, okay, we all know that, 5 on the right. Okay, let's start with the inequality X less than 5. Solid or hollow, circle. Hollow, arrow to the left or to the right? Left, all the way, draw it all the way. Next one, solid or hollow? Solid, circle, left or right? Right, okay, now, you see 3 regions again. Let me shade the first region. This is my first region. Then I've got another region, let's say, over here. Can you see? Very faint, huh? I've got another region over here until this part. And I've got a third region over here. Agree? Where is my point of intersection? Where's my area of intersection? The middle one. How do we describe it? X equals to or greater than 1, is it? So like that, negative 1 you mean? Then on the other side, smaller than 5. Do you agree that it's smaller than 5, or is it smaller than or equal to 5? Smaller than. You see, whenever you have your number line, right, it makes things very easy for you because all these numbers, they are shown on your number line already. Do you see that? And whenever you have a region in the middle, and you have a smaller boundary and a larger boundary, in this case -1 and 5, we always have it like that. Okay, this is what we can see, sometimes see. Sometimes we will see it like that, depending on the type of question. Sometimes you'll be like that. Sometimes you'll be like that. Okay, this is for regions in the center. Got a bounded by a smaller number, bounded by a larger number. Will we ever see solutions like this? This one? Can? No, we will not. We always put the smaller number on the left. That's why it will always have this sort of shape. Smaller number on the left. Okay, let's say you want to have a solution that looks like this. Give me a possible number over here. Randomly choose a number. Okay, let's say it is 2. What is a possible number over here? -1. Okay, does this make sense to you? X is less than 2 but it's greater than -1. Is this possible? Yes, it is possible, but do I have my smaller number on the left? No, I don't. So this inequality over here is actually describing something that looks like this. -1 and 2 from here to here. Right? But instead of having the smaller number on the right here, we always want to put a smaller number on the left. So it should look like this. Get it? Okay, another one. Very strange one. And we really see it. Something like that. Have you seen this kind of thing before? Does this make sense? No, we cannot have this kind of shape. It must always look like one of these 4. Okay? This is presentation. Nothing else accepted. Can? Okay, let me pause a while. Okay, and JC lah. Okay, next we have part D. X less than -9 or equal to -9 and x greater than 0. Okay, so number line, we've got -9 over here, 0. Okay, x less than or equal to -9. Solid or hollow? Solid. Left or right? Left. With an arrow. X. Solid or hollow? Right. How many regions do you see? How many regions do you see? Let me highlight the regions. I've got one region over here. I've got another region over here. And I've got my last region on the right. Okay, which of these regions shows an intersection? None. There is no area of intersection. What does this actually mean then? The inequality has no solution. What does that mean? Give me a random number. 3, okay? 3. 3 lies somewhere over here, right? Does 3 satisfy this inequality? Yes. But does it satisfy this at the same time? No. So 3 doesn't work, right? Okay, try another number. -2, okay, she selected a negative value. Does it satisfy this one? No. Does it satisfy this one? Also no, right? So negative also cannot be the answer. Okay, give me another answer, another number. We tried 2 regions already, right? Let's try -10 lah. Okay, -10, does it fall under this inequality? Yes, but does it fall here? No, it doesn't, so it doesn't work. There is no solution to this. Okay? If you compare with your previous examples, now okay, let's look at this one. Then we try substituting in numbers, okay? This is our question, and this is our solution. X is greater than or equal to -1 but less than 5. Give me a number, any number. Okay, you try 3, it is somewhere over here, isn't it? Does 3 satisfy this inequality? Yes, does it satisfy this one at the same time? Yes, it does. So 3 works. And you see that it falls under our solution over here. Let's try a number that is outside of this blue region. Try a number. -3, okay, it will be over here. We see obviously that it satisfies this, but it doesn't satisfy this. So you see, we must have a solution that satisfies both at the same time. That works for simultaneous inequalities and simultaneous equations. Okay? It satisfies only one, so it can't be our solution. Because -3 is less than 5, right? So it satisfies that one. But it doesn't satisfy x greater than or equal to -1. Yeah. Okay? Your turn to try, Ken. Let's try it 6, question B and D. Try it 6, B and D. How long do you think you need? 3 minutes, okay. 1:42. Sorry, 10:42. For both, watch the screen. X less than or equal to -2, and is there a difference between the word and or? Because you will need to know that in subsequent chapters also. The difference between and or. So x less than or equal to -4. Number line x. -4 is smaller on the left, so -2 over here. You agree that the answer is therefore x less than or equal to -4? Okay, all got that. Then for part D, we've got x is less than or equal to 7 and x greater than 2. Okay, let's draw a number line again. 2 and 7, x is less than or equal to 7. X is greater than 2. Therefore, x must be, so you see, I am not going to include the value 2. Okay, I'm going to put 2 on this side. X is greater than 2. Then on this side, I am going to include the value 7. Okay? Is this the answer at the back? Yes. That's it. Manageable? Or is it easy actually? Easy lah. Okay, now example number 7. Take a look at example 10:49. Actually, I think less than 5 minutes will be done already. You finish? Okay. Do you have a number line? You must have a number line, huh? Okay, who needs more time for this? Resign. Okay. After this, I have something to tell you about number lines. About presentation of number lines. Okay, because I haven't shown you the full picture yet for number lines. There is a certain way Cambridge wants us to present. Done already? Okay, let's look at try 7. 5x minus 8 less than. 12. And 7x plus 3 less than 17. So obviously for the inequality, we try to make x a subject also. So 5x is less than 20. X is less than 4. And 7x is less than 14. X is less than 2. Agree with me so far? Do you all have this? Okay, so now I need my number line. X, 2 and 4. X is less than 4. X is less than 2. So this is my region that I require. This, what I've just shown over here, is just a rough working. If the question says, show your answer with a number line, then you need to convert this to become this. Okay? Then we have x is less than 2. This is our final answer. Can? Okay. What if we have solutions that look like this? Okay. For example, negative 10 and 50. Okay. How will you describe the solution to this? X is the number over here, and then another number over here, right? Okay. What do I have over here? Negative 10. Then what is the inequality? Less than or equal to, because it's colored. Okay. Then on this side, less than 50. Agree so far? Okay. If we ask you to show your answer in a number line, answer in a number line, this is not enough. This is just a rough working. Okay, this is what you have. This is just a rough working. Answer in a number line is going to look like this. X, negative 10, 50, from here to here. Can you see the similarities between my rough working and my final answer? This final answer. Yes? Why? What? What's your question? Do you have a question? Uh-huh. No, negative 10 is less than or equal to x. Right. Okay. So can you transfer or transform workings like this into final answer like this by yourself? Can you do that? Are you confident of doing it? Later there will be some examples we try again, okay? Yeah, this will be our final answer. You will have a working over here, then this will be our final answer. Okay? Now let's go to try it 8. This time I want you to show your answer in a number line as well. Okay, let's take 3 minutes for this. 10:53. Inequalities, 6x plus 9 less than or equal to 2x plus 13. Slightly more complex now. And 2x minus 8 less than 7x plus 12. So the first linear inequality, we've got 4x less than or equal to 4. X is less than or equal to 1. On the other side, we've got negative 5x less than 20. X is greater than 4. Negative 4, yes. I always make this mistake. Okay, x is greater than negative 4. So put them all in a number line. X, negative 4 over here, 1 here. X is less than or equal to 1. X is greater than negative 4. Okay, so clearly we see that this is my area of intersection. So this is just my rough working. My final answer looks like this in a number line. So x, negative 4, 1. This will be hollow. Draw a line across. This will be solid. Okay, and my region will be x greater than negative 4 but less than or equal to 1. Got it? Okay. Very good. This is what we have, a fraction. X plus 1 over 3 less than x minus 2 over 4 less than x. Okay? This time, you don't have linear inequality and linear inequality. Then what are we going to do with this? Okay? We are not going to solve this gigantic inequality just like that. I'm going to separate them. Okay? Watch carefully. I'm going to separate this blue one. It is one linear inequality, right? Do you know how to handle this blue one? Make the denominator the same. So we multiply throughout by 12. Yes, we multiply throughout by 12. That is trying to solve the blue one. We have another linear inequality. It is over here. Agree? The green color one. So now I have two already. Then the format is the same as the previous questions. Okay, so let's do them separately. In the blue color one, I've got multiplying by 12 throughout. 12 times x plus 1 over 3 is less than 12 times x minus 2 over 4. This is the blue inequality. Okay, at the same time, I also have another one in green. 4 times of x minus 2 over 4 less than 4x. Do you agree that now my one inequality is separated into two different inequalities? And at the same time, I see one step, I try to get rid of the denominators, so I try to get rid of fractions already by multiplying with the common denominator. Agree so far? Okay, so for the blue inequality, let's continue. We've got cancel 4. So 4x plus 4 less than, use a pencil, cancel, this is 3 over here, less than 3x minus 6. And if you like, you can do the other side already, but let's just focus on one first. So here we get x less than negative 10. Right? And then on the other side, the green color one, we've got x minus 2 less than 4x. I can subtract x on both sides. I get 3x over here. I get negative 2. Therefore, we got 3x is greater than negative 2. X is greater than negative 2 over 3. Agree everything? Now then, last step is the same already. So we have our number line. X, negative 10 over here. Negative 2 over 3. X is supposed to be greater than this. X is supposed to be less than negative 10. Is there any region of intersection? No, there is no solution. Okay, no matter what value of x you choose, you put it back into this linear inequality, you will end up with a problem. So there is no solution. Any questions? Okay, then can you try it 10? So this is my solution. Even if you got it correct, you also need to pay attention because the answer at the back of the textbook says no solution, right? So you need to check whether your steps are the same as mine. Okay, so let's separate them into two parts again. Blue one and the green one. So for the blue portion, this is what I have. If you like, you can copy it down first. X plus 1 over 2 is less than x. Then in the green one, this is what we have. X, copy it down exactly, x less than 2x minus 5 over 3. They must both be satisfied at the same time. So if you like, you can put the word and over here. In blue, we've got multiply by 2 on both sides. X plus 1 less than 2x. X must therefore be greater than 1. Am I right? Yeah, I'm right. Okay, then we've got an and. Green color? 3x less than 2x minus 5. X less than negative 5. Is this what you had, Gaius? Yeah, x greater than 1, x less than negative 5. Let's see whether it is possible for this to happen. X is greater than 1. Over here, x is less than negative 5. I don't see any region of intersection. So this must mean that there is no solution. No matter what value of x you choose, you will never be able to satisfy the original equation. And what do I mean by that? Let's try. Randomly give me a number to substitute into x. Any number you like. Any number. 2, okay? Let's see what happens when I sub x equals to 2. So 2 plus 1 over 2, supposed to be less than 2, but supposed to be less than 2 times 2, minus 5 over 3. This is what it's supposed to mean when we sub x equals to 2 inside. Okay, let's continue down and we see whether there is any problem with this or not. 2 plus 1, 3 over 2. 3 over 2 less than 2. Does it make sense so far? 3 over 2, is it less than 2? Yes, it is. Now what happens on the other side? 4 minus 5 is negative 1. Negative 1 divided by 3 is negative 1 over 3. Does this portion make sense? It doesn't make sense. How can negative number be bigger than 2, right? So this tells me that, yeah, actually x equals to 2 doesn't work. You can try any number you like. All of them will not work. Okay? What is the reason behind it? We have worked it out already. See these two regions, they don't intersect at all. You can't have a solution. Can? Okay, so I think we have time for one last question. Let's try it 11. I give you 3 minutes, okay? 4 minutes. So 11, 11. Okay, so now try 11 in blue and green again. So in blue, I can choose to multiply throughout by 3 if I want to. I can choose to add 2 to both sides. Okay, let me copy it down first. Negative 5 less than 4x over 3 minus 2. In green, this is what I have. 4x over 3 minus 2 less than or equal to 2. Okay, so let's work with 1 first. 4x over 3, I add 2 to both sides, I've got negative 3 over here. So 4x over 3 is greater than negative 3. 4x is greater than negative 9. X is greater than negative 9 over 4. On the other side, 4x over 3 less than or equal to 4. 4x less than or equal to 12. X less than or equal to 3. Do you have that? Okay, so number 9. X. I've got a negative number over here, negative 9 over 4. I've got a positive 3. X is less than or equal to 3. Solid circle to the left. X is greater than 9 over 4. Negative 9 over 4. Hollow to the right. This is my area of intersection. If I convert this into a number line, this is what it must look like. Hollow, solid. Integers in between, okay? It is more useful to write negative 9 over 4 as negative 2 and 1/4 for us to visualize. Negative 2 and 1/4. So what are the integers in between? I've got negative 2, negative 1, 0, 1, 2. Do I include 3? Yes, I do. So the answer will therefore be negative 2, negative 1, 0, 1, 2, and 3. Manageable? Okay, homework question. Let's have 3 homework questions. Let's do this quickly. 40x greater than 430. 4x greater than 43. X is greater than 43 over 4, which is how much? 10.75. Okay, x must be more than 10.75 months, right? So what is the number of complete months required? Excellent. So minimum number of months equals to 11. What if my calculation, give me 30 seconds. What if my calculation results in me having this answer? greater than 10.01. What is the minimum number of months now? 10 or 11? How do we round? We want complete months, right? You see, x is greater than 10.01, even though it's 10.01, can we have 10 as the answer? So the answer will still be 11. Okay? Take some time to think about it. Okay, so the homework questions were as such. Okay? If you like, you can go and do more questions, which I'm sure you are more than capable of doing.